What do numbers like 5 nanometers and 10 nanometers mean when talking about processors? And what is its importance? If you follow the technical news regularly, then it is likely that you have seen news of Intel is still experiencing problems in the manufacture of 10 nanometers processors. Or the next generation of phone processors will use a 5 nanometers architecture, for example, as the talk about processors, whether computer or those devoted to phones, is always cantered around these numbers usually. And it is clear that it has great importance because companies are trying to reach lower values for them and always treat the new values as a big leap in the field. In this video, we will try to explain the meaning of values such as 5 nanometers or 10 nanometers that a lot of news talk about today, as we will address the basis of these values and what they measure specifically, and we will also address their importance and their impact on the quality of the processor, its speed and even its thermal output. To understand this, one must know something very important about processors, which is that they are mainly composed of very small transistors assembled together within the processor. These transistors are the main part of the processor that allows it to perform operations on the inputs and convert them into an output. As transistors are in principle logic gates that give a specific output according to the input provided to them, and the greater their number and frequency of work, the greater the power of the processor. Of course, there are three main factors that affect the number of transistors in a processor: the total size of the processor, the size of each individual transistor, and the distance between the transistors themselves. For example, computer processors are much larger than processors for smartphones, and therefore they usually have more transistors despite using the same architecture. In contrast, newer processors usually contain more transistors than older ones, since the size of each transistor is smaller and the distances between them are shorter. Of course, a value like 10 nanometers here is supposed to express the distance between each transistor and its neighboring transistors or elements, and this value is actually infinitely small, since 10 nanometers means 1 part of 100 million parts of a meter, and even compared to the past, the transistors in use today are 1,000 times smaller than those used in 1971, for example, and they are almost as many times closer to each other. Finally, it is important to note that the value of nanometer can be misleading when comparing different companies, as Intel's 10 nanometers architecture uses transistors with dimensions of 54 by 44 nanometers and the distance between them is 10 nanometers, and in contrast, TSMC's 10 nanometers architecture uses larger transistors with dimensions of 66 by 42 nanometers and with the same distance. So things don't always compare, and Intel's 10 nanometers processes compare more to TSMC's 7 nanometers processes. In fact, they are closer to the size of a transistor. What improvements could smaller transistors make? Over the years, the sizes of transistors used in processes have shrunk dramatically, as well as the distances between them. As processes reach distances smaller than 1000 nanometers for the first time in 1987, and by 2003 the distances decreased to 90 nanometers. And today 5 nanometers processes have begun to manufacture, with the expectation that 3 nanometers processes will soon catch up in 2022. Probably. Of the clear changes in dimensions, it is certain that companies always chase the smaller dimensions of transistors and the smaller separators between them, as it is important enough to spend billions of dollars annually on research and tests from many companies around the world, and the matter here is very important without a doubt, as companies that reach the use of transistors smaller and matrix closer to each other in its processes before the rest have a major advantage in several things, such provide a higher level of performance, In various processes, there is a certain limit to the size that the processor can actually occupy, especially in portable devices such as laptops, tablets, and smartphones. So, usually one of the most important factors affecting performance here is the number of transistors that can be placed together to accommodate their processor. By reducing the size of the transistors and the separators between them, it is possible to increase their number within the processor, of course, and as a result, it is possible to obtain clearly higher levels of performance than the previous one from a processor of the same size and use the same port even in some cases. As one of the most important changes that the processors have received is that they are now accommodating more transistors and thus may include a larger number of cores. And the huge performance difference can be seen from the fact that modern economic processors of the current generation often outperform the best processors available in the market 10 years ago. Reducing the need for energy and heat output. In short, smaller transistors are operable with less electrical power than large ones, and thus newer processors that incorporate smaller transistors usually consume less energy in general. Or at least they can provide more performance if they consume the same energy. And in many products where the power source is a relatively fast depleting battery, the energy consumption is actually enormous. Of course, there is an additional matter related to energy consumption. Since the processor consumes less energy, this reduces the thermal output of the processor. As the high temperature of the processor is an unwanted side effect of electrical tools, and reducing it is very important in terms of reducing the need for cooling systems, fans and vents, or even allowing designs completely devoid of effective cooling, but rather relying on heat loss to the body, as in smartphones and tablets.